Hello, all. I thought I would share some of my experiences in trying to get ElasticSearch working on my Windows PC. Thought I would share this just in case anybody else ended up needing to do the same thing, as well as, some of the things I came across. Just a disclaimer, I do not claim to be an expert in any of this stuff. As a matter of fact, I was just exploring this. I know that there's talk, Amazon Web Services has a service called the Amazon Elasticsearch service, which provides, a managed service up there in the cloud for really lightning fast indexed text searching and all that. So my understanding about Elasticsearch is it's basically wrappers the very, very reliable, extremely quick Lucene text search engine. And, so being that we work in a Windows Microsoft shop, we're doing a lot of .NET Core development and all that. Thought we'd take a look and see what's involved with getting standalone Elasticsearch up and running on a Windows platform, and then like writing a proof of concept or a spike against it. Because once you can get that working, then the rest is just basically deploying it up to the cloud and looking into clusters and Elasticsearch clusters and things of the like. So what I did, and I'll try to make this very short and concise. Basically, what I did is I went to the elastic.co site and I downloaded Elasticsearch and Kibana. I didn't really look at Beats or Logstash, but basically I downloaded the zip file for Windows there for Elasticsearch and the zip file for Windows for Kibana. And after I downloaded it, I went ahead and installed it. Or actually, you don't really install it. You just basically unzip it to a directory. As you can see, I got two folders there. And, so in order to start that up, I went ahead and made a couple of quick changes to the config file in each directory. So taking a look at this, in the Elasticsearch folder under config, there's a file called elasticsearch.yml. I just changed a few things inside of there. The file itself is commented out, all the entries. I uncommented out cluster name, put whatever you want there. Node name, put whatever you want there. And since I'm running this locally, I don't really care about restricting, who can and can't come in. So I just opened up the whole world for cores. For brevity, I put these options in there. And then the same for Kibana in the config directory for your Kibana. There's a piece in there that is commented out. You're going to want to uncomment out this elasticsearch.url. And basically, Kibana is it's like an external, used to be Marvel. It's got all kinds of features associated with it from, manage dashboard. I'll show it in a second. But anyways, uncomment that out and just point it to your localhost 9200 because that's what the default Elasticsearch port is. So to start this up, basically, I just go ahead and run bin Elasticsearch, and that's going to fire up the and you also need to make sure that you have Java installed, preferably 1.7 or greater. So it's starting up the Elasticsearch engine there. And we'll do the same thing for Kibana. So let's start that up. Bin Kibana bat, and just want to kind of let them both come up. And there we go. So once you have that started up, you can then browse to your local host. If you look here, you can browse to your localhost 5601. And it'll go ahead and start up Kibana. And so basically you can go into your dev tools and then you can start running queries or issuing commands and stuff like that to your Elasticsearch engine. And so I have a few test ones in here that I wanted to paste in. So again, this is not a deep dive. This is just basically a kickstart to get you going, to get it started up so you can do further research. And then I provided a proof of concept or a spike that I wrote in C#.net, running .NET Core 1.1, which can be ported up to 2.0 compiled. And so, and I'll provide a link. So I have this out in GitHub. A disclaimer for this thing, it is, it was just a thrown together, quick and dirty kind of an application. In no way, shape, or form would I write something like this in a production level application. This is just, we're all used to this as developers, just throwing spikes together. So it's basically a ASP.NET Core 1.1 web application. As a matter of fact, I didn't even, I'm not even injecting the service in the startup. So technically, in a real production application, you'd probably want to bring in the Elasticsearch engine and stuff like that as a service so that you can inject it into the constructors of your controllers or any other place that needs it. So this proof that I put up there in the GitHub, I'm not doing any of that. I just basically, this doesn't even have a UI associated with it. So I was just testing it out by setting breakpoints. So please forgive me there, but it should be enough to get you going. But let me go ahead and run it. And when I run it, you will see, what the outcome of this is for. So first of all, I've created some indexes. This is from previous runs, so I apologize. I should have deleted those, but that's okay. When you start for the first time, you're probably not going to have any indexes created and things of that nature. But let me go ahead and start up the application and just kind of show you, what happens there when you do that. As a matter of fact, before I do that, I'm going to try to delete this content index if you remember how that works. There we go. So I just ran. So this Kibana has a kind of a DevTools dashboard, which similar. It's kind of like Postman, but it's their own. As you can see when you highlight over this, it highlights the whole block. But I went ahead and deleted this index that I was playing around with. I created. So basically, if I run a query on it, it tells me it's empty. Basically there's no records in this particular index. I called this thing content index or IDX, and basically in Elasticsearch, IDX or an index is similar to the concept of a collection in MongoDB or NoSQL, or if you want to think of it, it's kind of like a table in an RDBMS. But anyways, the key is think of this as I have this collection called Content IDX, and it's going to have a whole bunch of content. That's the thought. So in case you wanted to go ahead and search by content, and this application here is going to go ahead and load content in it and run some queries against it. So right now it's empty because there's no records in it. So if I fire up this application, I just kind of wanted you to see. Again, it's really hacky, but it does the job for a spike and a proof of concept. And by the way, this is using the they call it the Nest API for Elasticsearch, and it's basically a NuGet package. And if you wanted to go and take a look at it, it's considered the de facto, from what I understand, the de facto .NET engine for Elasticsearch. It's been around for several years, and it seems like it's got a lot of frequent updates to it. The documentation is pretty good too. So anyways, have a look at that too. But anyways, it's ported into this project. So I'm going to go ahead and start this up and give it a second to load. And like I said, it's just using the default ASP.NET API front end. So anyways, this is bad hacking on my part just to test it. The index is method is going to go ahead and just call this. The reason I put it in a web app is just to prove that this can run in the context of an ASP.NET Core 1.1 web application. So what this is going to do is it's going to connect to the ElasticSearch engine that I have running, which is this guy right here. And there's a whole bunch of things you can read up on it, but there's a whole bunch of settings you can do for when you configure it. And all I'm doing right here is Elasticsearch persists your indexes. Again, think of those as tables, if you will, that contain data. And all I'm doing is every single run here, I just want to start with a clean slate. So if the index exists, if there's data in it, for example, I'm just going to go ahead and delete it. So you start with a fresh slate over and over again. And then this line of code here is like creating a table, if you will, content IDX. And what I wanted you to know is this structure right here, this class, I'm going to have basically each entry is going to be like a content entry. So it's going to have its own ID, it's going to have its own date and its own text. If you use your imagination, I'm basically simulating, let's say you have your content stored somewhere in a CMS or a SQL Server database or Oracle, or it don't matter, it could be Mongo or whatever. But anyways, the idea is you would pull out the data from that table, and then you would populate your Elasticsearch, shall we say, persistent store via an index. So I'm just calling it content IDX. You can call it anything you want. It should have called it like content table or whatever. But this is how you create it. This map basically defines a schema for it and says all the entries inside of this particular index is going to look like this, going to have these three fields inside of there. That's basically what this map and this auto map, says use all three of these fields. If you look in the documentation, you can get pretty elaborate on how you want to put your fields in there. But again, since this is a spike, I'm just defaulting to all. Then I'm going to go ahead and insert some records. So, I'm inserting 5 records into the database here. This is how you do your insert into. This is kind of like a insert into each row. The naming is kind of interesting. At first glance, it looks a little misleading, but when you see this, just know that we're iterating through this collection and we're inserting a record into this table, even though it's called IDX. So the idea behind that is after this method runs, and before we get to testing some of the searches, we should have some data in that particular collection. So I am finished right there. I'm finished actually inserting those records. So if I run this query again, down here, I just highlight it and hit that green button. As you can see, here's our records. So they all pretty much, they're the same. They got the content ID, and they got some metadata around here, the type, the score, which is which you get back from searches, and you can kind of explain that in a little bit too. But anyways, we got 5 records. I got some identical content in here. So this, then we jump into the next part, which is doing a term query where you match terms. So we have, this is how you would actually, this particular query right here looks just like this. So what we're doing is we're iterating through all of the records in our content IDX database, if you will, finding any records out there that actually have the phrase Louis, because I got some values of St. Louis, but having the phrase Louis inside of text. So we iterate through those. And if I set my breakpoint like, right here, it's going through each of these records one by one. You can actually check, each document as you get it back. As you can see, we got St. Louis Cardinals baseball because there's one right there. And, apparently that's not apparently, that's the way I set it up. There's only one record, and that actually has that particular term. So let's see what we got here. And then we go here for the next one, which is, we're looking, let me see here. We got term. Yeah. I apologize about the gap there. I was getting myself a little confused. It appeared that one of the searches didn't work, but it actually did. It's just that I was looking at the results from the previous search. So I apologize if I didn't. I needed to step past this particular line to actually get the query to execute. So I apologize. It just wasn't paying attention too well. But anyways, on the current term here, we're in hockey. And so if you look here at these records, for all these content, you're only going to find one out there that actually has the term hockey right here, and it's actually going to go ahead and find it. So if you highlight over your results, you can see the document here, and it's got the content text of hockey. So it's just going to iterate through that for each one of these, so you can test it out the way you want. And then the very next test after that is match phrase, which is a little bit different. So here we got match phrase, and then we got match. The difference between match phrase and match is match phrase is looking for the specific pattern, so it must have Chicago space Bears in the text, whereas up here, it'll find any documents that have Chicago or Bears, or you could have Bears space Chicago in the document, or just Bears or whatever. So that's the difference between the term and the actual match phrase. So I'd highly recommend you separate point there and check your documents, kind of like this. So on the first one, I'm looking for the quick, because we actually have a text inside or entry in here that has the quick. And if you notice, we also have the Chicago Bears. So we got the word the in two particular locations there. Let me step through that, and there's our phrase. However, in this particular case, it's looking for the quick. So it's looking for, where it starts with the and has quick. However, if this was basically a term instead of a phrase, then the and quick would be treated as two separate independent words to look for, in which case it would return this one and this one. So that's the difference between match phrase and in basically term. And then you can get kind of you can get kind of adventurous with filtering. So in the case of testing filters, which is the next set of tests that it's going to go through, this is where you can add conditions, ors, and all that. So all I'm doing here is I'm just saying, get me all the content where content ID is greater than or equal to 4, and there's a whole bunch of things that you can do filters on. So again, this is just to get you started. So if you look here, we got content ID 4, 3, 2, and 5. So we should only have 2 entries after that. This runs because it's greater than or equal to. So then again, what you see is 2 entries. You highlight over the document, and you're going to see content 4. And then the second one, you're going to see content 5. What I find interesting on some of these, and I should have mentioned earlier, is the concept of a score. So let me finish this and run this again, because it's something basically you just kind of wanted to throw out there. So I just refreshed that page again, so it's going to go through this whole flow all over again. So now it's inserted. It basically deleted the collection, reinserted the 5 records, and so let me go ahead and do one of these here. So if we do a result, I want to see where we get 2 back. So in this particular one, we get 2. We get 2 records because we're looking for the space quick. So it returned basically 2 on there. If you look here, we've got like a max score for that particular search. And what I find kind of interesting is for each record you get back, you get a hits array, and you can look in the hits array and you can see, well, for the first record, that score was a 0.084, and for the second one, that score was a 0.0632. So basically, it's just saying it found more matches in the first one than it did the second one. And where that could get kind of useful is if, you know how you do a Google search and you may find the most valid or most best searches or the highest ranking searches at the top of the page or whatever, and you want those to show up first. You could basically, you know, like a link query, just go ahead and do an order by, you know, hits, sub zero, sub score, or whatever, if you wanted these results to come back in that fashion. So that's, you know, pretty much all I'll say about that. Again, this is not really meant to be any kind of a tutorial, but rather this is just to get you going to where you can start doing some more research and getting past the pain points of installing it, firing it up, getting it to run in a .NET project, especially on Windows. I would like to refer you to what I thought was a very useful and just excellent blog post. And I put some links in the code, which, you know, is on the GitHub page, so in here. But the API has changed over the past several years, and it's using the Fluent API. But this particular blog post this is just an excellent post here, and it's got, you know, how you would do all of these queries and searches and things like that, along with a lot of good code examples. So I'd highly recommend reading that. And you know, I hope this this thing helped a little bit, get you going. And you know, from this, you know, you could go even further and take a Pluralsight course, or you could take an Udemy course, or whatever you need to do to further your knowledge on ElasticSearch. Anyway, so I think that wraps it up. I appreciate you taking your time out to look at that, and I hope it helps. So take care. Thanks a lot.